AI is a field in which we try to make machines more smart. And sort of traditional approaches to AI, they code certain rules into systems and they let the machines reason over these rules. And in more modern approaches to AI, which involve machine learning, we try to learn or make the machine more smart by having it learn from data or from historical sort of data. And so you can view this perhaps as, a system that has been programmed. The rules are fixed. If I'm standing in front of a red light, there could be a rule in a car that says if the traffic light is red, then you should brake and stop. Right? But for machine learning, you can view it as a program that constantly rewrites itself. So if it looks at data, it will try to improve its code base in order to become better in predicting the world, after it's seen that data. It's much like actually humans learn. So they play around, they test hypotheses, they try things out, and in that way they learn about the world and they make themselves smarter. Now within that field of machine learning, there is a subfield which is currently very hot, which is called deep learning. And in deep learning, we train a specific kind of model, which is called a deep neural net, that is inspired by how the brain works. So let me explain a little bit how that works. So in a brain, we have neurons and we have connections between neurons, which are sort of information channels that we call synapses. And if the channel is sort of wide, a lot of information can, be transferred between two of those neurons. And so when we learn, we change the capacity of these channels. So when these two neurons activate a lot together, then we sort of make the channel bigger and more information can flow through it. So in an artificial neural network is exactly the same. So we have sort of layers of artificial neurons, and in between we have connections. And when the network sees data, so it tries to make predictions. For instance, it looks at an image and it tries to see whether there's a car in the image. Right? Now, if it makes a mistake, then there's a signal that says you made a mistake, and then a signal propagates back through this neural network and tries to change the value of these channels to make them bigger or smaller, so that the next time around they look at the image, they will actually make the correct prediction. So not all artificial intelligence is based on machine learning or deep learning. There's also fields that do not use learning to make machines smart. But I would say the trend is that most of AI now makes use of machine learning technology, because the best way to make machines smart is really by learning from data. And so the traditional way to think of AI maybe is of robots that walk around in the world and interact with the world. But there's a lot of other ways that you can have smart machines or smart algorithms. For instance, on your phone, there's algorithms that that are guiding you through life. For instance, it tells you where to go using your navigation system, but also recommender systems. So if you try to find your next movie on Netflix, so there's a recommender that tells you what movies you might like. Or if you buy a book on Amazon, then there's all these recommenders. So there's a lot of other ways in which algorithms are smart. For instance, also search. If you search on Google, that's a smart algorithm that not necessarily take the shape of a robot. Right, so I think the most important thing that happened around, I'd say the 90s, or no, sort of later, around 2010, is that we would get a huge computational power by the fact that we figured out that we can use GPUs, which are processors which are actually doing the rendering, the video rendering in computers, and we could leverage those to train large neural networks. So it's particular the compute power which has been driving the progress in artificial intelligence. At the same time, of course, a lot more data became available as well, and these models only start performing very well when there's a lot of data available. And all of that fueled into much bigger and stronger models with lots more parameters that we could train. For instance, we can now train models with almost 1,000 layers, where before we were stuck with maybe a few layers. And so the extra flexibility and the extra power that we have in these neural nets make the models a lot stronger. So artificial intelligence is, on one end, you consider it as an efficient computational system. There are certainly algorithms that are not more than that. For instance, you can think of simple search methods or simple sort of navigation methods for your car, GPS methods. But there's also algorithms which are starting to behave a lot more like real intelligence, or the way we would consider real intelligence, like AlphaGo, which is the engine that beat the world champion in the game of Go. So there we saw quite sophisticated moves. In fact, they looked highly original, and they would maybe considered even be superior to human Go players. I think when these systems become more and more complex, we will see intelligent behavior that is recognized as either human or superior to human. But you could also imagine that they look a bit alien to us. So maybe it's a different kind of intelligence than humans have. And so it's not necessarily that if a system becomes very intelligent, that it is an intelligence that we can easily relate with. AI currently is very good in doing predictions that are sometimes better than humans, but in a very limited domain. So, for instance, there are systems now that can diagnose skin cancer better than any dermatologist can. And similar things have happened in digital pathology and other sort of limited domains. If you have a lot of data, restrict yourself to a limited domain, then we can build systems that are extremely good. Also, AlphaGo is an example because it's also the domain is very limited. But they're not very good at flexible behavior. Like humans, they can behave intelligently in many different kinds of environments, even in environments that they have never ever seen before. And so the current AI systems, they don't have that type of flexibility. So in other words, they don't understand enough about the world yet in order to behave intelligently in different environments. So in terms of the job market, many people have claimed that AI will displace a lot of workers, and in specific areas this might happen. For instance, in truck drivers, if the self-driving car and the self-driving trucks become a reality, it could happen that a certain generation of truck drivers loses their job and find it difficult to reschool into a new job. But on average, in general, I think that even though the labor market will change, certain jobs will go, but also other jobs will be created around sort of the opportunities that are provided by AI. The challenge maybe is to identify those new opportunities and to reschool people into those new jobs. And so there's a big responsibility there for universities and schools to make sure that people can quickly sort of reschool into these new opportunities. I believe we can create a world where privacy will be maintained, even though we will develop very powerful machine learning and AI algorithms. But we will have to change things. So currently, our data get absorbed into big companies, and we don't think much about what happens after that. If we would change the system where we own our own data and we have control over our own data, then you can imagine systems that learn off of that data in a way that is even privacy preserving. So in other words, if an algorithm comes to my data and says, I would like to use your data to train a little bit of my model, then you could specify what level of privacy you require for that update. and then it will only look at sort of averages. It will not actually update the model in such a way that later somebody else can recover sort of sensitive data that you provided for that learning. So I strongly believe that in the future we will see the emergence of new algorithms which are perfectly privacy preserving, but still can learn from all the data that is around. Right, so there's two ways that computation can be done, especially to power AI algorithms. One is you compute and train in the cloud, which is a bunch of servers somewhere, in some place. And so you would have to send the request for processing to those servers, and there's clearly delays involved, and also it might be an unreliable connection. But also you might not want to share your data with the servers, and so there's a bunch of disadvantages. The other thing is that you can actually do the computation on your device locally. So that means that you don't suffer from these delays or latencies, and that you can maintain privacy. But of course, in order to be able to do that, we will have to be able to build powerful enough algorithms that they can run on the device, and also in such a way that they don't use a huge amount of energy. Otherwise your battery is drained very quickly. But I do believe that these algorithms are possible, and we are developing these algorithms. And in the future, I think more and more of that computation will actually happen on the edge, on the devices that we have. And in terms of the impact that it will have on Internet of Things, of course, we will put more and more devices everywhere, in our cars, in our homes, in our offices, and we carry them on our bodies. And so if we want to have AI applications running on those devices, we will have to be able to do the computation locally and on the device. I think in terms of automated driving, in the beginning, when the systems are not perfect and the media attention is very much focused on it, every accident will probably be under a magnifying glass. But if you look at the actual statistics, we probably find that that it's actually a lot safer to have automated driving than have human driving. And so it's a matter of trust. So will we as a society start to trust these cars? And I believe that we will, because at some point in the beginning it might feel uneasy, but at some point we'll find that we will have the experience that they actually drive very safely. Part with the actual statistics that the number of accidents will go down, not go up. We will probably start to trust these systems. Like, in some sense, we also trust planes that they will land for us, although there's still somebody in the cockpit. I do believe that in the future we do not need somebody behind the steering wheel anymore. There is a new law, GDPR, in Europe that requires algorithms to explain themselves when they make decisions that impact humans. On the one hand, that's a good thing. Clearly, when these impacts are negative, if I need a loan and an algorithm decides for me that I cannot have that loan, then it's desirable to understand why I cannot have that loan. But we should also not fool ourselves that this is actually always possible. So when these algorithms become more and more complex, it becomes harder and harder for these algorithms to explain precisely why they come to a decision. So I think it's very hard for AlphaGo to explain to us why they made this famous move which won a game. We can come up with some approximation of an explanation, but it will not actually reflect the true complexity of the algorithm as it runs. So I think at some point there will also have to be a certain trust in the system. For instance, if a system that diagnoses you when you get to the doctor and sort of recommends a treatment, you can choose a simple algorithm that can perfectly explain itself, or you can choose a very complicated algorithm that performs a lot better and makes it more likely that you will recover. but that cannot explain itself very well. So personally, I would choose the more complex algorithm and simply trust it. So it depends also a lot on the application. In terms of the loan, I might actually demand an explanation for why it was rejected. But I think it will depend a lot on the particular application that we're looking at, and maybe we will just have to sort of be satisfied with simple explanations that do not actually reflect the full complexity of the decision. It's very hard to look in a glass bowl, but I would think that there's two developments which are particularly exciting in terms of artificial intelligence in the coming 5 years. The first one is probably augmented reality. So I think we'll see glasses, wearables, which will project information on top of the real world. We can project all sorts of interesting things on top of the real world, which is going to be a very powerful device to have. The other one is probably interactive chatbots. So in the future, it will probably be possible, again, in maybe a somewhat limited domain, to have a conversation with an AI system that sounds, almost indistinguishable from a human conversation. And that has also, of course, many applications. So in terms of skills that we need to learn in schools to prepare for modern future AI, I find it somewhat strange that even at a young age, we don't learn about coding and software and more about technical skills. So currently we learn a lot of sort of natural languages in school, which is great, but we don't learn coding languages, which I think is strange, especially given the fact that digital technical innovation affects our daily life so much. We spend a huge amount of time on our cell phone, and we don't understand how a cell phone works, and we don't understand what happens to the data trail that we leave on that cell phone. So that's on the technical side. I think it's also important to train people less and less in very specific jobs, because the labor market is probably going to shift and change, and more about learning to learn, being creative and, changing, skills in an environment where that is necessary.